everyone, welcome to Dual Decimal Division. My name's Eric Larson and this is part 2 in a series of videos I'm calling The Secrets of the Numerals, where I'm sharing with you some of the elements or designs or foundational aspects of geometry that are contained within all of the various numerals. So what I've done in the first video is show you how to draw this series of circles here, this pattern. I'm focusing in on the first 4 rings of the pattern. And what's interesting about this particular pattern is that each of the rings contains or is defined by square root radius that's in the consecutive order. So the first circle is a radius of 1, second circle is a radius of square root of 2, then square root of 3, square root of 4, and so on. So somebody used this particular pattern to generate the various designs for the numerals. You can see there's a real sequence in there. And so we're going to go to the second circle in the series, and we're going to use the relationship of that circle to the grid underneath to come up with a numeral, or we're going to see how somebody else already did this, a numeral that represents the number 2. So what we're going to do is, first of all, just look at that circle and how it sits on the grid, and we're going to look for the lattice points that define the radius of that circle. So we can see, basically here we are, 1, 2. This is a spot where the horizontal and vertical lines are intersecting each other, and that's a point there that intersects with the circle. So we're going to follow it around and see we have another one here, and then here, and then up to here again. So those are the 4 lattice points where the circle is sort of like attached to the grid. So now what we're going to do is basically or simply connect those points by tracing lines that are already drawn on the grid. So we're going to start with this curve at the top here. It's going to trace the curve of the circle, or the circumference of the circle, with the radius of the square root of 2. Then we're going to connect these 2 points right across the center, just like that. And then I'm going to connect these 2 points at the bottom, just like this, drawing a line along the base. And there we have a symbol that represents the number 2. And the first thing you want to look at that, or that's interesting to note, is that the length of this bottom line is 2. And this is something that all the numerals have. They all contain the value of the number that they represent right in the symbol. So I'm just going to write that down here at the bottom, just that number. And we're going to go through and just see what the lengths of all the different sections of the symbol are, because that's what's interesting about this, is all the numerals not only contain the value of the number they represent, but a lot of other aspects of the number, or qualities of the relationship to the square root of the number to the value itself, and just different elements that all kind of overlap each other to give a lot of meaning and significance of the symbol to the number that it represents. So basically what I'm saying is this length here also has some aspects of 2 to it. This length here is the length of 2 times the square root of 2. You know, we've got that's the diameter of that circle. So I'm just going to write that down here also. 2 times multiplied by the square root of 2, or 2 root 2, is the length of this line. And then this portion of the circumference here, we know that the circumference of a circle is 2 pi times the radius. And the radius here is the square root of 2. So 2 times the square root of 2, and here we have, it's divided by 4. This section here is 1/4 of the circle. I'm going to divide that by 4, so the 2 cancels out and the 4 turns into a 2. So we have the square root of 2 pi divided by 2. So there's a whole lot of 2 happening in terms of the defining of all those various lengths in there. So that's basically, in a nutshell, why the numeral that represents the number 2 looks the way that it does. So I'm going to put the whiteboard behind so you can see that more clearly. There you go. So that's, again, why the numeral that represents the number 2 looks the way that it does. That's like the bones of the symbol. I know when you look around, you can see a lot of different variations or fonts or designs of the elements of the 2, but it's got the curved top, which all the 2s have. and then it goes from the top right to the bottom left. In a sense, the pattern goes down that way, then there's a flat bottom. So all the components of the numeral that represent the number 2 are in this symbol. It might look a little bit angular or jagged, but that's, again, the bones or the essence of that symbol. And that's what we're going to find for all of the symbols, is that the basic ingredients that make up that symbol are related to the geometry of this pattern that I'm showing you. So again, each numeral is going to relate to the circle with the square root radius of the number that the numeral is supposed to represent. That's how this all works. So now we're going to go to the next numeral in the series, or the next ring in the series in that pattern, the third ring in the series, the circle with the radius of the square root of 3, and we're going to see why the numeral that represents the number 3 has the distinctive shape that it does. So hope you can join me for that. Thanks for watching.